Good morning, everybody. Today we're going to do a quick review of, we're going to do a quick review, not that thick of a pencil, of area and volume. Okay, so let's start off with a regular polygon or a two-dimensional shape. So we're going to start off with just a basic square. Okay, so to get the area of a two-dimensional shape, that's the space inside this shape here. And we want to find out, basically we want the base and we want the height. And because for the area of a square or a rectangle, it's going to be base times height. Now, we can also use this information, this basic information, to find out the area of other shapes. But before we do that, we want to explain, well, why is the area of a rectangle base times height? So I want you to try and visualize it if you just had a straight line. So let's do it beside it here. And that would be a base. Okay, and then that's only a one-dimensional kind of line. It's just the distance. However, if you wanted to stack those lines on top of each other, you're adding that second dimension, which is, in fact, our height. So to find how many lines you would have, you would add them all up, add all these bases, or simply times base times the actual height, or how many of those lines you would have. So that's just a quick explanation of why area of a rectangle is base times height. Now, even if we were given a parallelogram, we can split it into triangles. Even if we were given a trapezoid, we can split it into rectangles and triangles, or we can split it into two triangles, and we have lots of options. However, we're simply using what we know already. Even if we were given a funky shape, so even a more difficult one like a hexagon. Let's see if I can draw this now. Like so. Again, we can think, well, it looks pretty tricky, but use what we know already and we can split it into those various shapes that we already know how to find the area of. Quick tip and a quick note is be really careful with our triangle. For example, if we have a funky triangle like this, be careful when finding your base and finding your height. I like to just rotate, say for example, if this triangle was like this, there's no clear base. I like to rotate it or redraw it so that at least one of the edges are actually horizontal or on the ground. So for example, this one here. Now we can look and say, well, that's our base. What's our height going to be? Our height, remember, has to be the distance from the ground or the base to the tallest point in the triangle. However, it has to be straight up. So if we think about the highest point, it's going to be this one here, but it has to be the vertical distance from that point to the base. So if we bring down our vertical distance, it looks something like that. So our height is going to be this dimension here. So be really careful for those types of triangles. Right, now let's move on to looking at a three-dimensional shape. So when we do that with like Let's draw a rectangle again, and we'll talk a bit about our units as well as we go. So if we draw a rectangle again, our units for finding the area of this face are going to be, say for example, centimeters squared or meters squared. We've got that 2 as an exponent up here. And a nice way to remember this is you have 2 dimensions, a base and a height, to find that area. Now, if I wanted to add a 3rd dimension, let's extend this rectangle to make something like this. We're adding in that 3rd dimension. So not only do we